In this video, I am going to describe you about the expression evolution and typecasting in Python programming language. What is an expression? An expression in Python is any valid combination of operators, literals, and variables. That's mean an expression is composed of one or more operations with operator, literals, and variable as the constituents of expressions. The expression in Python can be of any type: arithmetic expression, relational expression, logical expression, string expression, compound expression, etc. Now if you write a plus b, so this is an arithmetic expression. If you write a less than b, this is an relational expression. Suppose you have a condition 1 or condition 2. Expression which contains logical operator are called logical expression. So there may be a string expression and compound expression also. Compound means if the expression involves multiple type of operators, that is, the compound expression involves arithmetic as well as relational as well as logical expression. In this video, I am going to describe you about the arithmetic, relational, and logical expression, and that will be sufficient for the beginners. Before starting expression evolution, you have to know about the precedence, that is the Python operator precedence. The following table lists all the operators from highest precedence to lowest. So if an expression contains more than one operators, so which one will be executed first and which will be executed later? So that will be decided according to this precedence list. Operators which are at the highest precedence must be executed first, and the comparatively lower precedence will be executed later. So look at the table carefully. I have written the highest precedence at the beginning and the lowest precedence at the end. So this double star, that's mean exponent operator, it has the highest precedence among all operators. Next to it there is complement, unary plus, and unary minus operator. These three operator has the same precedence, so it is written in the same line. Next to this unary operator, there are multiplication sign, division, modulo, and float division. All these four has same precedence, so it is written in the same line. So whichever comes first in the expression will be evaluated first. There is no concept of BODMAS rule as we do in mathematics, normal mathematics. Python follows its own rule, so you have to know about this rule. Next, the binary plus and minus operator. It has lower precedence than serial number 1, 2, and 3. Now if an expression contains this exponent, multiplication, and plus, so exponent will be calculated first, then multiplication will be done, then addition. After that, this is bitwise right shift operator and left shift operator, both has the same precedence. Next, bitwise AND, then bitwise JOR and bitwise OR, they have the same precedence. Next, all the relational operator less than equal to, less than, greater than equal to. Next to it is the assignment operator, that is the equal to and not equal to. Now next come to augmented assignment operator. So equal to, modulo equal to, slash equal to, double slash equal to, minus equal to, plus equal to, multiplication equal to, double star equal to. Next is the identity operator, is and is not. Then membership operator, in, not in. And at last, the logical operators has the lowest precedence among all operators shown above. So what are the logical operators? Not, or, and. But notice carefully, among the logical operator, not has the highest precedence. Then and, then or. So among these three logical operator, OR has the least precedence and not has the highest precedence. So this is all you have to know about the precedence. Now next, you have to know about the type conversion. The process of converting the value of one data type, it may be integer, string, float, etc., to another data type is called type conversion. Python has two types of type conversion: implicit type conversion and explicit type conversion. So before starting any expression evolution, you have to know about the type conversion along with precedence. So let me show you about the implicit type conversion first. So implicit type conversion, also called the coercion. In implicit type conversion, Python automatically converts one data type to another data type without programmer's intervention. An implicit conversion is applied generally whenever differing data types are intermixed in an expression so as not to lose information. Now let me show you an example. When we are going to evaluate an arithmetic expression, at the same time I will show you how the precedence and implicit typecasting works. So let me take this example. Say a equal to 42.0, that's mean a is float. B equal to 7.0, 7.0 is float, so b is pointing to 7.0, that's mean b is also float, and c is initialized with 6, that means c is an integer. Now you are told to evaluate this expression x equal to a divided by b multiply c divided by 2. Since multiplication and division both have the same precedence, so whichever comes first will be executed first. Let me write down the same expression as x equal to a divided by b multiply c divided by 2. Now this a divided by b comes first, so you have to evaluate this one first. Then the result of a divided by b will be multiplied with c. Now the result of a divided by b multiplies c will be divided by 2. Now a variable is float. B is also float. So when a is divided by b, it will give you a float type answer. So these two operations will give you 6.0, which is also a float value. Now here c is integer, and it will be now multiplied with this float value 6.0. So if any one of the operand becomes float, the result will be typecasted to the float only. So when this c, that is 6, is multiplied with 6.0, it will give you 36.0, and it is a float value. Next, the last operation, that is divided by 2. This 2 is an integer, and again when it operates with this 36, that's mean 36 divided by 2, since 36.0 is float, 2 is integer, so again it will be typecasted to a float value. That's mean 36 divided by 2, it will give you 18.0. So note carefully, suppose you have two arguments, say a1 and a2, in an expression. Suppose a1 and a2 is operated by some operator. Within these two arguments, if any one of the operator is complex, the other will be converted to complex also. And this is done by the Python interpreter automatically. If any one of the argument is a float type, the other will also be converted to the float type. And there will be no conversion if both operands are integer. Next, let me show you how to evaluate relational expression. So let's take this example. Here are two sets of inputs. Look, for the first one, a equal to 10, b equal to 20, and c equal to 20. And for the second case, a equal to 20, b equal to 10, and c equal to 10. Now we are going to evaluate these sets of lines for the first input value as well as for the second input values. Let's see what will be the result. Now for the input combination 1, the output would be, the first one is print a less than b. Here a is 10 and b is 20. That's mean 10 less than 20. So the condition is true and the output will show you true. Next, b less than equal to c. That's mean 20 less than equal to 20. B is not less than, but they are equal. So b equal to c. That's mean this is also true. Now a less than b less than equal to 20. That's mean a is 10, b is 20, and c is 20. So a less than b is true, and 20 less than equal to c, that is 20, is also true. So it will give you true finally. Now if we evaluate these three expressions by taking the input combination a equal to 20, b equal to 10, and c equal to 10. For the input combination 2, where a equal to 20, b 10, c 10, the output would be, let us check, a less than b. A means 20, B is 10, that's mean 20 less than 10. No, this is not true. So it will give you false for the first statement. B less than equal to C. B means 10, C is 10, less than equal to C. That's mean 10 less than equal to 10. It will give you true. Now A less than B less than equal to C. Here A is 20, B is 10 and C is also 10. Now this condition is true, but this condition A less than B is false. So in this scenario, if any one of the condition become false, it will give you a false value. So this is how a relational expression works. Let me show you the same example by typing it into the Python interpreter. Suppose A equal to 10, B equal to 20 and C is equal to 20 also. So if you write print A less than B, it will give you true. If you write print B less than equal to C, it will also give you true. And if you write print A less than B less than equal to C, this is also give you true. Now if you change the values of A, B and C, suppose A is 20, B is 10, let's write B and C in the same line. Both B and C are initialized with 10. Now if you type the same thing, let me copy and paste over here, it will give you false. If you type B less than equal to C, this is true. And if you print A less than B less than equal to C, it will give you false. Next, evaluating logical expression. Expression which contain logical operators and or not are called logical expression. Rules of evaluating logical expression. The precedence of logical operator is lower than the arithmetic operators. So arithmetic sub-expression is evaluated first, then logical operators are applied. The precedence of logical operator among themselves is not and or. So if a logical expression contains all three not and or operators, so not will be executed first, then and then or operator. Let us take an example to show how a logical expression works. Let me take this example. It's a big expression which contains arithmetic operator, logical operator as well as relational operator. All operators are present in this expression. 8 multiplies 6, it will give you 48. 4 multiply 12, it will also give you 48. This and not will be remain same. Now this will be checked first whether this 48 less than equal to 48. Yes, this will return true. And not. So within bracket 15 multiplies 6, it will give you 90. Not equal to, this is also 90. Next, this or, write down or, 12 plus 1, when true is added up with an integer value, then the true will be considered as 1. So let me write as 12 plus 1 and it will be checked with 26/2. So the quotient will be returned over here, that's mean 13. Let me close the parenthesis also. So now check 90 not equal to 90. What it will return? It will return false because both the 90s are equal. Now write down or, 12 plus 1, this is also 13, equal to 13. Again let me write down true and not. This will be false and 13 equal to 13. So it will return true. Now this expression will be evaluated then. So in case of or, if any one of its argument is true, it will return true. And the expression looks like true and not true. So this not true will become false because not of true will be false. again true and false. Finally, in case of AND logical operator, if any one of its argument become false, it will return false as a final output. So this whole expression will return false. Next, explicit type conversion. An explicit type conversion is user-defined conversion that forces an expression to be of specific type. We use the predefined function like int, float, str, etc. to perform explicit type conversion. This type of conversion is also called typecasting because the user casts changes the data type of the object. That's mean when we, the user, changes the type of an object to another type forcibly by using all this function. So that is called explicit type conversion. Suppose you have a variable s equal to say 1, 2, 3, 4 and a equal to say 56. Now you want to add this s plus a. So it is not possible to evaluate an integer with an string expression. So what you have to do, you have to just write down 56 and convert this s to integer. So when you are writing int within bracket a string, so that string will be converted to integer, then the addition operation will be done and the value will be stored within C variable. And if you type C, that's when you want to see the type of the variable, it will return it's an int type. Let me show you another example. Suppose you have taken a equal to say 7. So 7 is an integer. Suppose you want to store this 7 as a float value. So what you have to do, let me take a variable b, write down float and within bracket a. That's mean this a, that is 7, will be converted to float and stored within b. And if you type b, it will show you that it is a float type. Or rather, if you print b, it will show you 7.0, not 7. Let me show you the same example in Python interpreter. Say a is equal to 1, 2, 3, 4 and a equal to say 56. Now c equal to a plus, let me typecast this string to integer. So string 1, 2, 3, 4 will be converted to numeric 1, 2, 3, 4 and will be added up with the 56, that is with a. Now print c will get 1290 and write down the type of c. You will get it is an integer type. Let's take a equal to say 7. It is an integer. Suppose you want to store this 7 in float data type. So what you have to do, you write float within bracket a. That's mean a will be converted to float and then it will be stored within b. Now if you print b, you will get 7.0, not 7. So the type of b will be now float. So this is all for this video. Still, if you have any problem, write down in the comment box. I will try to reply you back as soon as possible. Thank you.